Hello everyone, I am A. Gayatri Acharya, Assistant Professor in CSC Department. Welcome you all to my video creation activity based on operating system. The topic of this video is contiguous memory allocation. It is the method to allocate the parts of the main memory in most efficient way possible. The operating system can be placed in either low memory or high memory, and the major factor affecting the location of interrupt vector. Programmers place the operating system in low memory since the interrupt vector is in low memory. This is a diagram of high memory and low memory in operating system with various addresses. In this case, each process is contained in a single contiguous section of memory. The memory mapping and protection played an important role for memory location. Generally, memory is divided into two partitions, that is resident operating system and user processes. But based on the memory allocation, it is of single partition allocation method and multiple partition allocation method. In single partition allocation method, the operating system resides in the low memory and the remaining memory is treated as a single partition. The single partition is available for user space, that is, only job can be loaded in this user space. This is an example of memory allocation for single partition, which consists of ready queue, low memory, and single partition user space. In this case, the short-term scheduler or CPU scheduler selects a job from the ready queue for execution, and the dispatcher loads the job into main memory and connect the CPU to that job. The main memory consisting of only one process at a time because the user space treated as a single partition. The main benefit of single partition is that it doesn't require great expertise to understand or use such a system. But the demerit is that it has poor utilization of processor and memory. The second allocation method is multiple partition method. In this case, when a partition is free, a process is selected from the input queue and is loaded into free partition. When the process terminates, the partition becomes available for other processes. This method can be implemented in various ways, such as fixed variable multiple partition, fixed equal multiple partition, and dynamic multiple partition. In fixed size scheme, the operating system keeps table indicating which parts of memory are available and which are occupied. Initially, all memory is available for user processes and is considered as one large block of available memory known as whole. When a process arrives and needs memory, we search for a whole large enough for this process. If we find one, we allocate only as much memory as is needed, keeping the rest available to satisfy the future request. In fixed partition method, which is a particular instance of the general dynamic storage allocation problem, which concerns how to satisfy a request of size n from a list of free holes. The various solutions to this problem are first fit, best fit, and post fit. Let's discuss one by one. First fit. It allocates the first hole that is big enough. Searching can start either at the beginning of the set of holes or where the previous first fit search ended. In best fit case, it allocates the smallest hole that is big enough, and this strategy produces the smallest leftover hole. In worst fit case, which is the last one, it allocates the largest hole. We must search the entire list unless it is sorted by size. In this strategy, produces the largest leftover hole, which may be made useful than the smaller leftover hole from a best fit approach. The various advantages are: it supports multi-programming, efficient processor utilization and memory utilization, and it is very simple and easy to implement. The disadvantages are suffering from internal fragmentation and external fragmentation, and possible for external fragmentation. Now let's discuss what is exactly fragmentation. Fragmentation occurs in a dynamic memory allocation system when many of the free blocks are too small to satisfy any request. It is of two types. Number 1, external fragmentation. Number 2, internal fragmentation. Both the first fit and best fit strategies for memory allocation suffers from external fragmentation, as we have already discussed. External fragmentation occurs when there is enough total memory space to satisfy a request, but the available space are not continuous. Depending on the total amount of memory storage and the average process size, external fragmentation may be a minor or a major problem. In external fragmentation, statistical analysis of first fits says that even with some optimization, given n allocated blocks and another 0.5 n blocks will be lost to fragmentation. That is, 1/3 of memory may be unusable. This property is known as 50% rule. Internal fragmentation. In this case, the space wasted inside of the allocated memory blocks due to the restriction on the allowed size of allocated blocks. Allocated memory may be slightly larger than requested memory. This size difference is memory internal to a partition but not being used. The solution of the problem of external fragmentation is compaction. Compaction is a goal to shuffle the memory content so as to place all free memory together in one large block. Thank you.